These are the last notes for Unit 6. These first couple examples, very similar to problems that we've done already. They give us a graph for f of x and a graph for g of x, and then ask us questions like f times g of 4. So f times g of, actually, we can't do 4. 4 is not on the graph, sorry. Let's do f times g of 3. So we would do f of 3 times g of 3. F of 3 means when x is 3, what is f of x equal to? The y value on f of x at x equals 3 is 3. G of 3, when x is 3, g of x is 1. So you do 3 times 1 is 3, easy enough. We've done problems like this before, just quick review. F of g of 1. Start inside the parentheses here, g of 1. When x is 1, g of x is negative 1. So we replace g of 1 with negative 1 and copy the rest of it. F of negative 1, when x is negative 1, f of x is negative 3. F of negative 3 is 1. So nothing terribly new there. I don't think we need to do a bunch of problems like that. But the ones I do want to take a look at, the ones that are a little different that we did not do in the notes, is a problem like this, where it asks us to evaluate, f of 3 to the negative first power, or g to the negative first of 3, or what looks like to the negative first. So let's take a look at these. This first one says f of 3 to the negative first. F of 3 to the negative first. First of all, the way this is written, this is not an inverse. This is not f inverse of 3. F inverse would be f, and the negative 1 would be the exponent on the f. So this wants us to evaluate f of 3 and then raise f of 3 to the negative first power. So f of 3 we discussed earlier, f of 3 is 3. So we have 3 to the negative first. Negative exponents just get moved down to the bottom. 3 to the negative first is 1. 1/3. The more difficult problem is this guy here. It asks us to evaluate g inverse of negative 3. G inverse of negative 3. The way we would do one like this is if it's asking me for g inverse of negative 3, I want to know g inverse of negative 3 equals what? That's what I'm looking for. That's the same thing as saying g of what is equal to negative 3. Remember, we switch x and y when we evaluate an inverse function. So what was my x is now my y. What was my y is now my x. I switched x and y. So if I can think through g of what gives me negative 3, I know g inverse of negative 3 is equal to that thing. So g of what? What x value has a y value of negative 3? On g of x, g of 2 is negative 3. G of 2 is negative 3. Therefore, g inverse of negative 3 is equal to 2. And that's what we're looking for. 2 is correct. And then the other thing we talked about in class today was finding domain. Find the domain of each function. The first one, let's go with f of x equals negative 3 times the square root of x plus 5 minus 2. F of x equals negative 3 times the square root of x plus 5 minus 2. So when you're thinking about what the domain could be, The domain, remember, is which x values belong to the function. So I'm taking a square root here. Square root, whatever I take the square root of this here, which in this case is x plus 5, I could take the square root of a positive number. That would be okay. I could take the square root of 0. That would be okay. But I cannot take the square root of a negative number. So x plus 5, the thing under the square root, has to be greater than or equal to 0. It cannot be negative. Therefore, x has to be greater than or equal to negative 5. So when we list out our domain, we say the values starting at negative 5 and going up to infinity, including the negative 5. Let's go f of x equals 2 times x minus 3 squared plus 4. F of x equals 2 times x minus 3 squared plus 4. Well, this time I don't have a square root. This time I'm squaring. When I square something, I can square positive numbers. I can square 0. 0 squared comes out to something. Negative numbers squared, that's okay. That's not undefined. I could take a fraction and square. I can square anything. Anything, x minus 3 is allowed to be anything. Therefore, my domain is all real numbers. All numbers from negative infinity to positive infinity. Number 3, g of x equals 4 times the cube root of x plus 6 minus 9. G of x equals 4 times the cube root of x plus 6 minus 9. Looks very similar to number 1 here, but it's a cube root instead of a square root. When I take the cube root, I can take cube roots of positives or negatives or 0. I can take the cube root of anything. My domain is all real numbers. Last one, number 4, y equals 6x minus 3 over 7x plus 2. When we divide, you can't just divide any two numbers. You can divide almost any two numbers. The one thing you're not allowed to do when you divide, though, is you cannot divide by 0. The bottom is not allowed to be 0. 7x plus 2 cannot be equal to 0. Dividing by 0 gives us undefined. Solve for x, so x is not allowed to be negative 2 over 7. X can be anything else. Any other value would give me a y value, but if x is negative 2 over 7, I don't get a y value, I get undefined. So when I list out my domain, I want all real numbers except negative 2 over 7. Using interval notation, it would be all the numbers from negative infinity up to negative 2/7, not including the negative 2/7, and then picking up again at negative 2/7 and going all the way to infinity. This is all values from negative infinity to positive infinity, except for negative 2/7 is not included there.